This is the video introduction to Activity 3.4, Completing the Square on the Quadratic Formula. This is Part 1, Squares and Square Roots. The purpose of this activity is to learn to use squares and square roots when solving quadratic equations. We'll learn to complete the square to find the quadratic formula and turning point form of a quadratic formula. We'll learn how to graph a general quadratic function and how it differs from the graphs of the simplest parabola, and we'll learn to analyze any quadratic function. We'll use our full set of algebra pieces. Looking at squares and square roots, in our previous work, we noticed that equations such as x squared plus 6x equals 7 are difficult to solve. However, if we set everything equal to 0, this allowed us to use the quadratic rectangle analysis to solve some similar equations. It turns out if components of the quadratic equations are square rectangular arrays, we can use additional techniques to solve these equations. Suppose we wish to solve an equation such as x squared equals 4. Previously, we would have approached this by setting everything equal to 0, x squared minus 4 equals 0. And then, as we saw in the introduction to activity 3.3, we would find edge sets to factor x squared minus 4. And we would solve and find that x equals plus or minus 2. However, because everything on the left side of the equation, that's x squared, is square, and everything on the right side of the equation is a number, we can use an additional, and in this case, faster technique for determining the solution to x squared equals 4. Well, we can think of this new technique in terms of algebra pieces, and we can also think of this new technique graphically. Matching a black x square and a 2 by 2 array of black tiles, we have a picture. So we have a black x squared equal to 4 black tiles. That's the same as saying x squared equals 4. A 2 by 2 array of black tiles has edge dimensions 2 by 2 or minus 2 by minus 2. Our black x square has dimensions x times x or minus x times minus x, but we'll use x times x in both cases here. This shows us again that x will equal plus or minus 2 when we match our edge dimensions with the squares. Graphically, if we graph our function y equals x squared and the horizontal line y equals 4, we see that those two graphs intersect when x equals plus or minus 2. X squared equals 4 is a particularly easy example. Both the left side and the right side of the equation are already square. Suppose we want to solve an equation such as x squared equals 2. In this case, we can't make 2 black tiles into a square array shape. Let's look at this using algebra pieces and a number marker. So we have a black x squared equal to 2. The dimensions of the black x squared are x times x or minus x times minus x. Thus, if we can find a number whose square is 2, the opposite of the number should also have a square equal to 2. By definition, the square root of 2, which we write as the square root of 2, is the number whose square is 2. Thus, according to the algebra piece model for x squared equal to 2, the dimensions of the black x squared must be the square root of 2 times the square root of 2, or negative the square root of 2 times negative the square root of 2. To solve x squared equals 2 directly, we take the square root of both sides and keep in mind that we should determine both the positive and negative answer. If x squared equals 2, then x equals plus or minus the square root of 2. You can see this is much faster. Graphically, again, we can graph both the function y equals x squared and the horizontal line y equals 2 and find those same 2 points of intersection. Note this new technique, take the square root of both sides, is really all we did to solve x squared equal to 4. And these two examples both have a simple x squared on one side of the equation. However, this new technique, taking the square root of both sides, works if one side is any square and the other side is any positive number. Why does the number have to be positive? Let's look at an example of taking the square root of both sides for the equation quantity x minus 1 squared equal to 2. When we solve this using our previous technique, we have quantity x minus 1 squared equals to 2. We take the square root of both sides. The square root of quantity x minus 1 squared is just x minus 1. So we have x minus 1 equals plus or minus the square root of 2. Adding 1 to both sides, we have x equals 1 plus or minus the square root of 2, which we can use a calculator to get numerical approximations for. 1 plus about 1.41 and 1 minus about 1.41. And again, you can see this graphically. If we graph the function y equals quantity x minus 1 squared, which is our parabola shifted to the right 1, and the horizontal line y equals 2, we see our same 2 points of intersection graphically. That's it for part 1 of the prep video. Check out part 2, the quadratic formula, and part 3, turning point form.